Welcome back to Aurora Tech Channel. Today, I will review the Creality SparkX i7, their new entry-level bedslinger that supports multicolor printing. The printer with the 4-color CFS Lite combo costs $399. It seems that's all you need to start 3D printing, even for multicolor printing. The design undeniably uses the BambuLab A1 as its blueprint. From a distance, you probably can't tell which is which. But let's take a look at what the SparkX i7 offers. The print volume is 260 by 260 by 255 millimeters, about 2.7% larger than the BambuLab A1. The table space required is about 30 inches wide if I rotate the CFS Lite 90 degrees. The depth is about 27 inches, including enough space for the bed to travel all the way from back to front. The vertical space required is about 27 inches to allow all the Bowden tubes to move freely. The motion system features a linear rail on the x-axis and dual linear rods on both the y and z axes. The main improvement of this printer compared to the Creality high-end K2 platforms is the hot end. In one of my previous K2 series videos, I pointed out that the Creality nozzle and heat break were too long, resulting in more purging than other AMS variants when switching filaments. As you can see on this new SparkX i7, the length from the nozzle to the entry point of the heat break is about 61.6 millimeters, which is about 23.5% shorter than the K2 or high platform at 76.2 millimeters. However, compared to the BambuLab A1's 49.2 millimeters, it is still about 25% longer. To make filament changes more efficient, Creality pulls the filament back halfway before cutting it. As a result, the filament remaining in the nozzle is much shorter than on other machines at just about 25 millimeters. Of course, a 25 millimeter filament residue doesn't mean it will save 3 times the purge compared to the K2 or twice the purge compared to the A1. We will definitely compare speed and filament waste across multiple printers later in this video. The nozzle on this machine can reach up to 300 degrees Celsius with a hardened steel tip, and the bed can heat up to 100 degrees Celsius. It uses the nozzle to probe the bed for auto Z offset and bed leveling. The top speed of this printer is not particularly fast. The maximum speed in the default print profile is 250 millimeters per second with a maximum acceleration of 6,000 millimeters per second squared. For additional features, it includes an HD camera for print monitoring and time-lapse recording, an LED light, and a privacy cap for the camera. At the front of the printer, there is an LED strip that can display the progress of your print and the different statuses of the printer. On the screen, there is also a night mode that reduces the print speed to 50% and turns all lights off. I would like to thank Creality for sending us this machine to review and for sponsoring today's video. As always, even though this is a sponsored review, I will still point out any issues or drawbacks I find during testing. This helps give potential buyers a realistic expectation and also offers useful feedback for the manufacturer to improve future firmware and software updates. With that said, let's get started. The printer and the CFS Lite came in one box. The top layer contains a print surface, toolbox, user manual, and an external spool holder. The fully assembled printer and the CFS Lite are protected by cardboard and foam, so we can simply take them out and they are almost ready to use. My review unit also includes an extra hot end. We will start by removing 2 blocks that secure the gantry during shipping. Then connect 1 cable from the CFS Lite to the machine. Install 4 Bowden tubes from the CFS to the print head. Since this machine only supports 4 colors, there is no splitter hub, and each color has its own inlet to the extruder. That's all we need to do, and the printer is now ready to use. When turning it on for the first time, the setup wizard will appear. Select your language, remove the blocks that lock the gantry, which we already did, and confirm that all other protective materials have also been removed. Next comes the agree to whatever it says screen. If you want, you can read all 16 pages on this tiny screen to see what you might not agree with. Then select your Wi-Fi network. It appears to only support 2.4 GHz networks. After entering your password, an IP address should be assigned to the machine. If you only want to print within your local network, you can skip the cloud service. The printer will then run a self-test. You don't need to do anything, just sit back and relax. When it calibrates the input shaper, you will hear vibration sounds. After that, it shows that a new firmware version is available, so we will download it before doing bed leveling. Once the upgrade is complete, it reminds you to do bed leveling, so we will manually select that on the screen. After about 5 minutes, it's done, and we can now load some filaments. I will mix different brands, including BambuLab PLA, Voxel PLA, Elegoo PLA, and Creality Hyper PLA. As you can see, the last spool is Creality Hyper PLA, which has an RFID tag, so the filament information is detected automatically. The other 3 spools require entering the type and color manually, so just select them on the screen. I would like to start a sample print, but to my surprise there are no preloaded color sample prints, so I will just print a benchy to make sure the machine is working. After it prints a few layers, I set up the meter for a sound test. The printer stays in the low to mid 50 decibel range most of the time, occasionally jumping to the high 50s during rapid movements. There is a night mode button on the screen, but it only reduces the speed to 50% and turns off the LED light, so I wouldn't count it as a special feature, since you can basically do the same thing on most printers. The print finishes in 32 minutes. For a standard speed single color benchy, it's not particularly fast, but the result is decent. The surface is fairly clean for a bed slinger, the cooling is good, and the bottom sticks well. The line width on the top looks normal, and there is no under extrusion. Overall, it seems everything is working fine. We will now go to the slicer and start our first color print. I have updated to the latest Creality slicer, which already has the profile for this printer. Let's take a look at the print speed settings. By default, the speed is set to about 180 to 250 millimeters per second. Travel is 400 millimeters per second, and the acceleration is between 2,000 to 6,000 millimeters per second squared. It seems both speed and acceleration are slower than other latest generation machines, but we will compare our prints with other machines and see. For this model, I will print this 40 by 40 square with 4 colors on each layer. So this 5 millimeter tall object is going to have 75 color changes, and the estimated time is over 2 hours. I will also compare the slicer estimate for both print time and filament usage with the actual print later. As switching between different colors will resulting in different purging volume, I will time each color change to see the difference. The first color change will be from skin to white. As you can see, before it cuts the filament, the extruder is actually retracting it from the nozzle. According to Creality, it will retract about 28 millimeters before cutting, so there will be shorter filament left over inside the heat break and require less flushing, resulting in less waste. Then, it will park on the right side. As you can see, the filament will only pull back a few inches instead of all the way back to the filament box. This could also save some time for color change. It will then do purging to clear the previous color. The total time used for this color change is 1 minute 19 seconds, which is a little faster than light-to-light color change on other printers, which requires 1 minute 30 to 40 seconds. Now let's time the change from white to gold. As white won't contaminate gold, so it basically took the same 1 minute 19 seconds time as skin to white. Now from gold to skin. Now from gold to skin, it still took the same 1 minute 19 seconds. Now from skin to white. When changing back to white from skin color, it took about 5 seconds longer. I think we're still missing the purple. Let's time another one from purple to skin. I expect this has to purge more filament and also require a longer time. As expected, from dark to light color change, it took longer at 1 minute 57 seconds, but it seems faster than other first-gen AMS setups that require 2.5 minutes. The print completed in 2 hours 13 minutes, and the filament usage is 41 grams. The model and the prime tower is matching the slicer estimate of 5 grams. The purge waste is about 24% more than the estimate 26.5 grams. The actual printing time of this print is also pretty close to the estimate. Let's compare this with other printers. When compare the SparkX i7 with the BambuLab A1, the time is a little faster and the purge waste is also slightly less. But the Elegoo Centauri Carbon saves an extra 9 grams in purge waste and prints 6 minutes faster. Of course, the second generation of BambuLab H2C is much faster and produces almost no waste. However, its price point is much higher. We will run more prints and compare it with different printers to see which one performs the best. You probably know what the next multicolor print would be. I will expand my Hello Kitty army. I will also time the color changes. Let's start with this pink to yellow change. Pink to yellow may require more flushing than other light to light color changes. It did indeed flush twice, and as a result, the time was 1 minute 38 seconds. When changing from yellow to pink, I expected it to be similar to light color changes that would not require much flushing. It took 1 minute 11 seconds, similar to those light color changes in our last print. Let's do the sound test again while printing multiple colors. When flushing filament, the printer is not moving at all, and the sound level stays in the low 40s. When it is printing, it stays between the high 40s and low 50s. When there are rapid movements, especially on the y-axis, the sound level jumps to the mid to high 50s. This print took 17 hours 48 minutes to finish. The filament usage shown on the screen is pretty accurate. It is just 10 grams less than the actual 398 grams. Compare with the slicer estimate, the model and support usage are accurate, with a difference of only around 2%. However, the purge waste is 36% higher in the actual print. The prime tower estimate is also very accurate. As a result, the total filament usage is about 13% higher than estimated. The time is also quite accurate. The actual print took about 2% longer than estimated, which I would say is within an acceptable range. Let's compare this print with other printers. Compared with the Creality K2 Pro, the K2 Pro, being a Core XY machine, is still faster than this bed slinger. The model and prime tower usage are similar, but the SparkX i7 saves 38% on purge waste. Compared with the Elegoo Centauri Carbon 2, the SparkX i7 is much faster, as the Elegoo slicer uses a honeycomb infill by default, which takes at least 10 to 20% longer on most prints. For purge waste, the SparkX i7 saves 23% compared with the Centauri Carbon 2. Finally, when compared with a multi-tool head machine like the SnapMaker U1, I do not think any AMS-style machine can do better than a multi-tool head printer in terms of both printing time and waste. I will do one more color print, Vegeta from Dragon Ball. Vegeta is the king of color contamination, especially in his Super Saiyan form with gold hair. I want to see if this machine can avoid that with less purging. This print took 8 hours 3 minutes to finish. The filament usage shown on the screen is once again very close to the actual amount. The model and support usage also closely match the slicer estimate. The purge waste is about 26% higher than estimated, and the prime tower matches the estimate exactly. So the total filament usage is about 15% off. The actual printing time is about 20 minutes, or 4% faster than estimated. I think the result is pretty good. When I zoom in on Vegeta's forehead, I cannot see any color contamination. Let's compare it with other printers. Compared with the Centauri Carbon 2, it is about 20 minutes or 4% faster, and the SparkX i7 has slightly less purge waste by about 6%. But when comparing it with the K2 Pro, the advantage of the SparkX i7 is obvious. The print time is 17% faster, and the purge waste is 43% less. When compared with another Core XY machine, the FlashForge AD5X, the SparkX i7 is 7.5% faster, and the purge waste is 32% less. Besides that, the SparkX i7 also doesn't show color contamination like the AD5X did. I will then run my benchmark test prints, starting with the number slider. This print mainly tests clearance. Most new generation printers can print this model pretty well, but a few years ago using Marlin-based firmware and the Cura slicer on an Ender 3 or even an Ultimaker S3, this model was difficult to print. This print took 3 hours to finish, about 9% slower than the average time of 2 hours 45 minutes for other new generation printers. The top looks alright. When printing this silk filament with this model, I found the text surface looks a bit rough, which also happens on most other printers. The bottom printed really well. You can clearly see gaps between the tiles, and all of them can move smoothly. Next, the honeycomb box. This mainly tests the retraction of the extruder. The extruder has to extrude a tiny drop of filament, retract immediately, and move to the next spot. The print finished in 3 hours 21 minutes, about 20% slower than the average of 2 hours 45 minutes. However, the print quality is very good. The retraction is clean, the tiny bottom patterns were printed without breaking, and the bottom is printed much better than average. Let's compare it with the same model printed by other new generation printers. The result is comparable to good quality printers that cost much more. Up next is the tolerance test. This test checks the flow and pressure advance to see if two parts with tight tolerances can fit together. I use Creality Hyper PLA since their own filament profile should be well tuned. The print time is 1 hour 37 minutes, which is in line with other new generation printers. On the square side, it can clear up to 0.05 millimeters. It is supposed to stop at 0, but it can still be inserted halfway. On the cylinder side, it can also clear up to 0.05 millimeters, but it can still be inserted a few millimeters, which it is also not supposed to. This suggests the flow is a little bit too low. When I checked the slicer, the flow rate was set to 0.95, which explains why it can clear zero tolerance. I think it should be set slightly higher, around 0.96, as I found most filaments work best between 96 and 98. The last benchmark is the surface quality test. Since the middle of this model allows more room for acceleration, the lower acceleration of this printer may also result in a slower print time, but we will see. This print finished in 5 hours 4 minutes, which is about 12% slower than the average 4.5-hour printing time. However, the print quality looks very nice for a bed slinger. Let's take a look from all 4 angles and then compare it with other printers. Compared with the Creality High, the High is faster right around the middle of the 4.5-hour average. However, the SparkX i7 surface quality is better. Compared to another bed slinger, the Sovol SV06 Ace, the SV06 Ace is even faster than most Core XY printers, but the surface quality drops when you push a bed slinger too far. Compared to the Prusa Mark IVS, the Mark IVS is a little slower, but the print quality is better, especially with the VFA in this area. Compared to the Centauri Carbon 2, the SparkX i7 is slower, but the overall print quality is obviously better. Compared with the FlashForge AD5X, the surface quality of the SparkX i7 is marginally better, as I can see less ringing on the surface. Overall, the surface quality of the SparkX i7 is on par with, or even slightly better than most budget Core XY machines. It's also better than most bed slingers, except for the Prusa Mark IVS, as the Mark IVS print even slower. I will also print a PLA sheet to test the Auto Z offset and bed leveling accuracy, as they have a direct impact on first layer quality. This PLA sheet is printed at 95 millimeters per second and finishes in 24 minutes. The lines are connected without separation. The top surface prints very well, with all lines squeezed perfectly onto the bed. The bottom surface with the PEI texture looks even better. This is a perfect first layer. Let's try some other materials. I will start with this PETG trash can. This large first layer also printed very well, despite PETG requiring slightly higher printing temperatures for both the nozzle and the bed. This print was done with 3 walls and took 6 hours and 37 minutes to finish. From a distance, the surface quality looks fairly consistent from top to bottom, but when zooming in closer, the top still has a bit more ringing than the bottom. You can see that the surface near the bottom is cleaner. The inside of the trash can was printed nicely with no stringing. The bottom stuck very well, and the first layer was beautiful. Generally, regular 95 ATPU may have problems when used with most AMS variants, but it seems the CFS Lite only relies on the motor at the top to pull the filament. So, even a 500-gram half spool of TPU can fit without issues. I will print a flexible tire using this Area 95 ATPU. The print finished in 57 minutes. The filament was stored inside a camera cabinet at about 30% humidity. It's not perfect, but still usable. The surface still looks all right. The inside has no stringing and is actually very clean considering the condition of the filament. Finally, I will try an engineering-grade filament, polycarbonate carbon fiber. I will still load it into the CFS Lite. Since the screen only allows 4 types of filament, I will just select PETG. Then I will go back to the slicer and edit the PETG profile, change the filament temperature range, nozzle temperature, and bed temperature to match the requirements for PCCF. I will also set the cooling to 20% and allow a maximum of 30% for overhangs. After that, I will save this PETG profile as PCCF, so the machine thinks it is printing a very high temperature PETG. Since the printing temperature of PCCF is 285 degrees for the nozzle and 100 degrees for the bed, I had to adjust the Z offset and move the nozzle up by 0.075 millimeters to compensate for the auto Z offset, which probes the bed at a lower temperature that works well for regular filaments like PLA, PETG, and TPU. This print took 4 hours and 2 minutes, and it was printed really nice. Look at the gear. It looks like it was printed by a much higher-end machine. The gearbox works very smoothly, and this 3-to-1 gear ratio propeller is very easy to launch. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The shorter new hot end is more efficient. I think the key improvement is that it retracts the filament before cutting it, leaving only about 25 millimeters of residue inside. As a result, filament changes save around 50% or even more compared to Creality's own K2 and high platforms. It also saves about 15 to 20% compared to the BambuLab A1 and other already efficient new generation printers, making it the most efficient single extruder AMS variant currently available. 2. The surface quality is above average, it's comparable to the Prusa Mark IV, and better than some entry-level Core XY printers. One reason is that the input shaper is well calibrated. Another is that it prints slower than most new generation printers. As a bed slinger, I would rather keep it slower than push it too far to chase speed and sacrifice print quality. Besides the surface quality, the retraction of this extruder works well. In the honeycomb box test, it not only completed all the sides without broken patterns, but the bottom was also printed very well. The result is better than most other printers at a higher price point. The tolerance is almost perfect. If the flow rate in the slicer had not been set slightly too low, at 0.95, it would have been perfect. 3. It can handle a wide range of filaments. A 300 degrees nozzle and a 100 degrees heated bed are not the highest specs, but they are sufficient for most common materials and even most engineering-grade filaments. As you can see, I was able to print beautiful parts with polycarbonate carbon fiber on the stock setup. Of course, if you need to print ABS, it is always better to choose a fully enclosed machine because nothing can stop ABS from shrinking, which leads to warping and layer cracking, except maintaining a stable ambient temperature. 4. The quick swap hot end is very handy. Unlike previous generation Creality machines, where you needed a wrench or tools to replace the hot end, it is now a one-hand operation. The latch locking mechanism also pushes the hot end upward to ensure it fits perfectly without leaving any gap. 5. The CFS Lite is super reliable. I didn't encounter a single filament loading or unloading error during the entire test. The best part is that it handles all kinds of filaments. I was able to feed a 500 grams narrow spool of TPU and even very stiff materials like PCCF, which are challenging for most AMS variants. It is also enclosed to help prevent moisture. I am very happy with this CFS Lite since it eats almost everything. You basically don't need the external spool anymore. Now for the cons. 1. This machine is designed to pair with just one CFS Lite, so the maximum number of colors it can support is 4. Generally, I won't print more than 4 colors on a single extruder AMS-style machine, as the filament waste is still significant, even with this more efficient new design. 2. It is not only slower than core XY printers, but also slower than most other new generation bed slingers. Personally, I do not see that as a huge drawback, since a bed slinger is supposed to print slower. If speed becomes more important than achieving the best print quality, you still have the option to increase it by 25% using the screen. I would still prefer to keep it at its slightly slower default speed. 3. When the printer is printing at extremely slow speeds and the Y-axis travels at top speed, the noise is a bit louder because it doesn't have active motor noise cancelling like the A1, which reduces high-pitched stepper motor sounds by analyzing and counteracting vibrations. I think that's the only feature where this machine falls short of the A1. 4. After a firmware update, the printer requires you to redo auto bed leveling. Creality released 2 firmware updates during my testing, and each time it prompted me to level the bed again before starting a print. I don't have to do this on most other printers. Moreover, since the printer already probes the bed in the print area before every job, I am not sure why this step is still necessary. In conclusion, this is the best bed slinger from Creality since they moved from Marlin to Clipper firmware. It's also their most efficient multicolor printer in terms of filament waste. It not only saves about 50% of Purge waste compared to the K2 and High series, but it's also more efficient than most single extruder AMS variants on the market. The print quality and the eat-all capability of the CFS Lite, which can handle small TPU spools and brittle carbon fiber filaments, make it stand out. The drawbacks are a slightly slower print speed, support for only 4 colors, and some minor firmware issues. Because the multi-filament reliability and purge efficiency are exceptional, I will award this printer the title of the best performing entry-level multicolor bed slinger on my recommendation list at auroratechchannel.com. I also added links to this machine in the video description. Also, don't forget to check out my website, auroratechchannel.com, which tracks prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.